Hi, in this tutorial, we're going to look at how to evaluate the UN expression for a sequence. Now, our UN expression is simply the formula used to determine each term of our sequence. And in our examples, we're going to be determining the first 5 terms of each of our sequences here. Let's begin with part A. We have that UN is equal to 4 times n minus 1. Now, as we go through, you'll realize that this is a lot like functions. Our first term is u1, which means that n is equal to 1. So this will be 4 times 1 minus 1, which is going to give us 3. u2, our second term, 4 times 2 minus 1, simply replacing n with 2, that's going to give us 7. u3, placing n with 3, gives us 11. u4, replacing n with 4, that gives us, so that's 4 times 4, subtract 1, gives us 15. And u5, 4 times 5 minus 1 gives us 19. Now, what I want you to realize here, which is going to be very important, I'll first write out my 5 terms, 15, 19, my first 5 terms. Now, what we notice is that each term differs by 4. So to get from u1 to u2, I add 4, u2 to u3, add 4, and so on. Now, this is indicated by the fact that our expression is 4 times n minus 1. So for n automatically tells me that my terms go up in steps or increments of 4 because they have this 4n term here. Similarly, if I had 3n, that tells me that my terms will go up in steps of 3. Negative 2n would tell me my terms go down in steps of 2. And that's going to be very important as we learn how to write our UN expressions. So bear that in mind. Now let's go to part B. Just draw a line and I'll come right here for part B. UN is equal to n plus 1 divided by n. u1, 1 plus 1 divided by 1, which is 2. u2, 2 plus 1 divided by 2, which is 3 over 2. u3 gives us 3 plus 1 divided by 3, which gives us 4 over 3. u4, 4 plus 1 divided by 4, 5 over 4. And u5, 5 plus 1 divided by 5 equals 6 over 5. So our first 5 terms would be 2, which I can write as 2 over 1, 3 over 2, 4 over 3, 5 over 4, and 6 over 5. So those are my first 5 terms. And if we wanted to show that goes on indefinitely, we can just put dot 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 dot. Alright, moving on nicely. Now at this point, you may want to pause the video and try the examples yourself, since you most likely have the hang of it by now. So you can go ahead and do that and just use the video to check to make sure that you have the right solution. UN equals 1 over 2 to the power n. And that's 2 to the power n, not 2 times n. u1 will be that's 1 divided by 2 to the power 1, which is 1 half. u2 equals 1 over 2 squared, 1 quarter. u3, 1 over 2 cubed, 1/8. u4 subscript equals 1 over 2 to the 4, which is 1 over 16, and u5 equals 1 over 2 to the 5, which is 1 over 32. So our first 5 terms will be 1 over 2, 1 quarter, 1/8, 1/16, 1 over 32, 1 over 32, not 13, and we go on dot dot dot. Now here I want to state the powers of 2. 2 to the power 1 is 2, 2 squared 4, 8, 16, 32, next would be 64. You will do well if you familiarize yourself with the powers of 2. In case you were given this sequence and asked to determine the UN statement, being able to recognize the powers of 2 is a very handy tool because it makes your life a lot easier when you have to start here and determine your UN statement. And you would also want to know that 2 to the power 0 is equal to 1. So you may have 1 as the first term, and then a half, a quarter, 1/8, 1/16, 1/32. So again, if you have 1 as your first term, we still have powers of 2 because 2 to the power 0 is equal to 1. Alright, now let's move on to our last sequence. U to the n is equal to -1 to the power n plus 1 times n divided by n plus 1. Alright, let's begin. Even though it looks complicated, let's just do what we know we have to do. U1, simply replacing n with 1. So that's 1 plus 1 times 1 divided by 1 plus 1, which will give us -1 squared times 1/2, which is, well, -1 squared is +1, so that's +1/2. Now u2 would be -1 to the power 2 plus 1 times 1 over 2 plus 1, which gives us -1 cubed times 1/3. Now -1 to the power 3 is -1, so this multiplication would be -1/3. Now let's just make some space up here to continue. U3, -1 to the power 3 plus 1 times 1 over 3 plus 1 gives us -1 to the power 4 times 1/4. -1 to the power 4 is +1, so we get 1/4. U4, -1. Now at this point I realized the pattern. I had to the power 2, then to the power 3, then to the power 4, so next would be to the power 5, which is 4 plus 1, divided by 1 over 5, because I've realized the pattern, so I've just condensed my work. So this would be -1 to the power 5 is -1, that's -1/5. And finally, U5, -1, this would be to the power 6 times 1 over 6. -1 to the power 6 is +1, so this is +1/6. Now writing out our sequence, we have 1/2, -1/3, a quarter, -1/5, and then 1/6. Now we realize that we have a sequence which fluctuates between positive and negative. Now we can tell that from our UN expression because of the -1 raised to power. what you need to note is that -1 raised to an even power. So here the power was 2, here the power was 4, and here the power was 6. -1 raised to an even power is +1. So again, -1 raised to an even power is +1. -1 raised to an odd power is -1. And because of that, we get our fluctuating nature between positive and negative. Also, you need to note that because of our index n plus 1, and n starts with 1, so n plus 1, our first term is positive. So we start with positive, then go to negative, and then go to positive. However, if we wanted to start with negative, our power would simply have been n, and that would have given us a negative term to begin with. So these are important things to note, especially when we are given the task of starting with our sequence and determining the UN expression. So thank you for watching this tutorial, and I hope that you found it helpful.